Many neutrinos were left over from the Big Bang, and it is possible that they have clustered around galaxies and are flying like moons if they have a non-zero mass around the galaxy. So it is possible that the galaxies are actually ensembles of neutrinos more than anything else, with a little bit of ordinary matter in the middle. On the other hand, for the universe as a whole, you know that we believe it started in a Big Bang. We still see the galaxies flying away from each other as a consequence of this original bang. Now, there is a force opposing the separation of the galaxies, and that is the gravitational force of each galaxy onto each other that is trying to stop the expansion. And there are three possibilities. Either the explosion was so energetic that the galaxies will fly forever apart because the mass in between them is not enough to recollapse them, or the in-between possibilities where the galaxies will separate till they eventually come to stop. Or there is enough mass to have the galaxies eventually come back. Those are an open, a flat, or a closed universe. Now, if neutrinos do have masses, since we believe many of them were made in the Big Bang, about 1,000 million neutrinos per atom of ordinary hydrogen, it is enough that they have a very, very tiny mass to contribute so much to the mass, overall mass of the universe, that the neutrinos themselves will pull the galaxies back eventually. So the fate of the universe depends on very few things, and one of them is whether neutrinos have a mass or they don't.
Perhaps the most promising measurement of the neutrino mass comes from a Soviet experiment undertaken at the Moscow Institute for Theoretical and Experimental Physics. In 1984, they concluded that the neutrino seems indeed to have a mass 1/10,000th that of an electron. To date, no one has been able to duplicate this experiment. The conclusions are tantalizing, but not as yet confirmed. The results of all the experiments on threefold unification are so far inconclusive. No protons have yet decayed. No monopoles have come through our detectors, and the neutrino mass experiments remain tentative. It seems to a growing number of physicists that they should reject the constraints of the experimental lamplight, which allows them to look only in certain places. They believe that substantial further progress can only come about by seeking an even more ambitious fourfold unification of all the forces, including gravity. To do this, they have to imagine energies beyond even the still unconfirmed point of threefold unification, because only there can one imagine that gravity will show any unity with the other forces. To go this far is not only to go way beyond experimental testing, but also to encounter immense difficulties in the theory. After all, the attempt to include gravity eluded even Einstein. But that story may have an ironic twist. In 1919, the very year that Einstein achieved world fame, Theodor Kaluza, a young German physicist, made a remarkable discovery. He took Einstein's equations of gravity and wrote them down as if they applied to a different world. Not the four-dimensional world of Einstein, but a mathematical universe with an extra fifth dimension.
To his amazement, he discovered that he had actually, when rubbing off the fifth dimension, the fifth coordinate, explicitly from the equations, he found that he had written down not only the theory of Einstein's gravity in four dimensions, the normal gravity, but also Maxwell's electromagnetism on the right-hand side of the equations. And so this was the first unification of Maxwell's electromagnetism with Einstein's gravity, achieved by extending space and time to 5 dimensions rather than 4. An incredible and a miraculous idea.
In mathematics, an extra dimension is a matter of algebra. One dimension, a line, is represented by one number, x. A two-dimensional surface by 2 numbers. Ordinary three-dimensional space by 3 numbers. You can't draw another dimension because there's no room for an extra line. But we can add an extra letter. In fact, mathematics can be done in any number of dimensions. Human brains are not wired in the right way to imagine life with an extra dimension. We're in the same position as a two-dimensional flatlander. In his world, he cannot imagine our space. If we push a pencil through his plane, he can't know where it's come from. All he sees is a circle which grows out of nothing for no apparent reason. Only flatland mathematicians can imagine the pencil which caused the phenomenon. We can perform tricks for the flatlander. To him, this disk is permanently stuck inside the ring. But with an extra dimension, it can be picked up and moved, leaving the flatlander mystified. Kaluza performed just as amazing a trick in physics by mathematically adding an extra dimension. It was quite obvious who should be told about his discovery.
What Kaluza did was he sent the paper to Einstein and asked him to get it published. And Einstein's reaction to this idea is in his letter. The idea that this can be achieved, that is to say the unification of electromagnetism and gravity can be achieved through a five-dimensional world, has never occurred to me and would seem to be altogether new. I like your idea at first sight very much. This was in April 1990. Then a week later, he writes again, raising a few, what now appear to us, rather trivial points or difficulties.
There was always this Einstein asked a question or made a suggestion, and then my father did something about it, sent it to Einstein. Einstein repeated or asked another question, and so on. There are 5 or 6 letters of this sort.
And then suddenly, in October 1921, 2.5 years later, he writes himself to Kaluza saying, I am now having second thoughts about having restrained you from publishing your idea on a unification of gravitation and electricity 2 years ago. I wish I shall present your paper, if you wish, I shall present your paper to the Academy after all. And then he did.
Kaluza's idea was picked up and improved by Oscar Klein in Sweden. But both men lived to see it become little more than an historical curiosity. Kaluza's disappointment must have been enormous. At the moment when he thought he saw how to combine gravity and electromagnetism, it must have seemed impossible to him for it to be merely an accident. His son was a small boy of 9 at the time, and he used to sit in his father's study while he was working. Usually, the father would work quietly by himself.
But one day, it was quite different. He sat completely still for several seconds, and then he whistled very sharply and banged the table. He stood up, and but he remained completely motionless for several seconds. And then he began to hum an area, or the last part of an area of Figaro. Dum dum da dum dum da 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 dum dum da 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 da.
Equipped with the multidimensional world of Kaluza and the guiding principle of symmetry, physicists have produced daring new theories that attempt to unify not only the 4 forces, but all particles as well. Today, Kaluza-Klein theories have been resurrected in a 10 or 11-dimensional form in connection with a new kind of symmetry, which goes under the grandiose title of supersymmetry. There is hot debate as to whether it's the correct road for theoretical physics to follow. But at the moment, supersymmetry is one of the boldest attempts to produce a single theory of all forces and matter in the universe.